Okay, so the vector database is one of the sort of slightly experimental tools that we're looking at as part of the tools group activities in the near future. This was built in response to a customer who built a brand new application starting about a year and a bit ago. And he came to me and said, I'm going to be generating a few 100 million records worth of simulation data, insurance simulation data. And I'd like a place to put it. I'm going to run this huge simulation, generate hundreds of millions of records, and then I'm going to do some kind of sensitivity analysis where I'm going to read it over and over again in different permutations, reading large subsections of this data and processing it. What would you recommend that I do with this data? I don't really want to put it into a relational database because I don't think that's going to work very well. And so the idea of the vector database was born, an efficient mechanism for storing large data. So not big data, but some number of gigabytes. The kind of stuff that I think is commonly found in large APL datasets. So certainly 10, maybe 100 gigabytes. I don't think we're really looking, at least not initially, to satisfy requirements larger than that. One of the things we really wanted to do, because we heard what the Optima people were doing with Cosmos and so on, we thought that kind of thing might become common in the future. So we wanted to be able to do parallel queries on this data, so break it up into subsections and use parallel processing to do queries. We wanted it to be open source, and in fact I have 2 people who have made a small number of commits. I'm expecting a few more in the near future. And we want it to be free. I mean, apart from the fact that it requires Dyalog APL, so it's not really free and open source software in the classical sense. We do want you to be able to update the data, but it's not intended to be a transactional system. Roy? Sharding is slicing the database up. So, in this case, it's if you have 100 million records, let's put 20 million each on 5 different servers and have them do, so that's called horizontal sharding for some reason. I suppose you're cutting them horizontally. I was sure that was vertical sharding, but there you go. So the focus is on really generating large quantities of data and then doing analysis, and maybe updating it a bit. So you're doing some modeling and then you'll go in and tweak the parameters for 100,000 rows at a time, which is the kind of thing you, again, wouldn't want to be doing with a classical relational database, but not sort of multi-user transactional system. That's not at all the intention. If you want to do that, you should use a real relational database system. And then initially it's focusing really on dealing with individual tables. That's something that I think we might change quite early on. But it doesn't support joins directly. One thing that it does have native support for, though, and that's the kind of thing that you really do want to shard, is sort of classical group by operations. So you've got 5 servers and you ask them each to do, select some data, do a group by, and then you collect the results in your front-end application. So, this is still a very small project. It's only a few 100 lines of code, but it's already in use in real applications. So there's only a few data types: Boolean, the 3 different integer data types, double precision, binary floats. And then there's a character type which is still quite limited, so it's actually stored in the database as a 2-byte integer, a pointer into a string table which is kept separately. Because for a large number of these applications you don't really have very variable character data, you have classifications of things. But we will soon be adding, I think, certainly much larger arrays of strings and a fixed width character type, so you can just have people's names and addresses if you need to have that kind of data in your application. Okay, and so the underlying technology for this is memory mapped vectors. Dyalog APL has been able to memory map arrays or files, represent them as arrays in the workspace for a very long time. I think it must be 20 years at least. And the nice thing about that is you can map arrays that are bigger than the workspace, and you only need to really be able to fit the selection, the results of your queries into the workspace when you're done. APL primitives, including things like key, will be able to work directly on the memory mapped arrays, I believe, without first bringing them into the workspace. They're just out there and accessible to the primitives. And memory mapping works very efficiently in modern operating systems. So if you want to create a vecdb, you might write something like this. You create a list of column names, data types, and then you can create a little namespace with options in. This case I'm setting the block size, which is how much the database is going to grow each time it overflows, 10,000 records. Create some random data here. It's not quite random. So I've got, what I've got here, 36 million records, some symbols, a price which is growing very nicely over time. And then you bring that together and say, make me a new vecdb. Is there a laser pointer here? Yes. Create a new vecdb with the parameters, and then if you like, you can provide the data up front and you have a new database. And what that actually does is it creates, we had three columns there, so we have 1 dot vector, 2 dot vector, and 3 dot vector. Those are simply the vectors. I need to hold my head like this, and it works. There's the character data, there's a symbol file, so the symbols for the second column. And then there's some counters, how many records are actually in there. Although we have full blocks, we can keep track of how many records have actually been created. And then there's a metadata file which contains the column names and so on. And that's it. And then we can assert that we have 5 records, db.count, and we can append the rest of the data, and it'll grow. The query language is extremely simple at this point. There's a function called query. You can have a where statement, you can select some columns, and you can specify some group bys. So if you wanted all the records for days number 200 and 201, you would just pass in something with a column name and then the values that you're searching for. If you wanted all the dialog records for those 2 days, then you can just specify tuples of column names and values, and they're always at the moment just ANDed together. So again, that's something that's likely to be extended quite soon. If you wanted to do something like this is how you would write it in SQL. You would say for symbol dialog, and then we actually use this kind of SQL-like syntax, a count to the price, max price, min price, and group by day. And it goes off and does that and returns the summarized data to you. You can also, if you don't select columns, you can get back numeric indices for the records, and you can then later use them either to read the columns or use them as an argument to the update function. So update these records, set the price to hike the price by 10% and update the database. A feature that was really added to allow people to do sort of very simple classifications of data rather than actual computations was you can have computed columns. There's a base column that they're computed from. It could be more than one. The type of the result that you're creating, and then simply the expression that you're computing. And then if you like, you can provide an inverse function so that the search mechanism can take your input that you're searching for, run it through the inverse function, and then go in the database searching for that value, rather than reading all the values out of the database and converting them and then searching in that. So if you're really trying to make use of the memory mapping, you don't want to read all the data. Right, sharding. So there's a slide about sharding. Horizontal sharding. The way you set that up is in the options namespace. When you create the database, you say, I'd like to shard using column number 1, which was the day number. And then you write an expression which has to return a dense set of integers. So shard number 1, 2, 3, 4. So we take the parity of the day number and add 1. So in this database, all the even days have gone into one shard and all the odd numbered days have gone into another one. That's probably not how you would set it up, but that depends on what kind of data you're using. And in that case, you get the symbol files in a central location and the metadata file, and then your shards are, in this case, just 2 folders where you just have the actual data and the count of records, the number of records that are actually in each individual shard. And the locations of shards don't all have to be on the same machine, of course. One of the points about all this is that you can have them located on separate hardware. Ideally for a system, the point of going parallel is really that you distribute the data out and then you do the processing close to where the data is. So either the slave machines that do the queries either have the data in their local file system or in some file system that they have very, very rapid access to. So you could have, I was going to do a demo here, but I gave up in the middle of the night. I couldn't quite get it to work. I had one shard on my Windows laptop. I had the other shard running on my MacBook to show that Windows and Mac can collaborate. And in that case, you also need to set up both what the names of the shards from your central location to use when you're initially populating the data, if you decide to do that from one place, and then the folder names that the shards will have on the machines where they actually run. Because if you're running them in a different location, the shard folders might actually have a different name as seen from the local machine. Anyway, so in addition to having the system automatically deal with the shards using a bunch of slaves, you could also open the individual shards one by one. So when you open a vecdb which is created, you can provide an additional constructor argument which says, well, I just want to use shard number 2. And what that would allow you to do if, for example, you're running a insurance simulation that's in itself, the simulation is a massive process that might run for hours. You can create the shards and then you can run the code which actually generates the data all on the machines where the shards will be stored, rather than generating it in one place and then pumping it through the database server and having it redistribute the data. So I think that's a technique that people will actually use when they're generating large quantities of data and then subsequently go via a parallel server and launch a server, connect to it, and then you get something which looks like this. This is something that's already up and running. So you could have 2 different machines serving the shards, a central master server that all the clients connect to, and it redistributes the queries. Well, at the moment, with their queries, it just broadcasts them to all the servers and aggregates the results. When they're updates, it actually runs the sharding of the data that's being inserted in the master and only sends the data to each slave that it's actually going to update or insert into the database. Okay, if you want to have a look at it, are we online, do you think? Is this going to work, Brian?
Good chance.
There it is. Okay. So it's all up on there on GitHub. And I say test-driven development, that's a little bit of a big word. But we have all the people who have contributed to it to date have been quite good at updating a test suite which takes the database through, uses all the different data types, all the different types of groupings, searches, updates, calculated fields, and so on. And that's been invaluable in being able to quickly, anybody who doesn't do development this way, I think you should really have a look at it. You have to have a test suite, regression test, unit tests, etc. All right, so last slide before we can get into it. Discussions that will wake you all up again with squiggles and stuff that might be added to APL. It's rudimentary, but it's already useful. There are 3 people who don't have it in production yet, but are actively looking at building commercial tools and using it as a prototype. There's more work to do, but I think it's already useful. It would be really good if you have this kind of problem, this kind of data, if you would take a look at it and let us know, help us prioritize the next steps in this journey. If anything, just contribute some test cases, right? I say it's very valuable if you're going to contribute to one of these open source projects, not just to actually make changes to the code, but if you have some scenarios, some test cases that you want to make sure that utility functions or whatever are going to support, contribute test cases to the repositories, even if you don't want to make changes to the code itself. Yep, and that is the story of vecdb as it stands. Does anybody think they might take a look at it, or is it too esoteric? Oh, okay, good. So it's not all a waste of time then. That's great. Right, with any tools-related questions, now we had all of those, and it's time to, Alexei. Lookups. Well, you can implement those using the mapped column technique, but that's noted, yes.
What data types do you support?
At the moment, it's integers. Let's see. Wow, this is even scrolling back through the presentation takes ages. Integers, float, and then characters are really just a symbol table. There we go. There it was. But I think that
things like date and
no.
Things like date or other things that you normally run into in a relational database.
Yeah, not at the moment. But that's not difficult. That's not difficult to add. It's mostly the functions that you would add on top of the integer values, which is what you would actually store in the database. Yeah.
I didn't understood how much multi-user is this. If you come to updating from different sources.
Well, if you go through the if you use it in the master server scenario, then it will be serializing the updates. Yeah. So it may not do it very efficiently, but it should all work. Tony, but you need the mic.
I'll do this just this once.
Do you shard by column as well as across?
No, not at the moment. But that wouldn't. You saw the file structure. That wouldn't be. That would be.
I would have thought it would have been easier.
A day or. Right, but the other one is more interesting, I think. For many applications, it's being able to maybe select the data faster by going to a particular shard because you know that's where the data is.
And the calculated field.
Yeah.
Is recalculated on the fly every time you do the query, or it's actually calculated and then stored in a column?
It's recalculated on the fly. Yeah. But again, that's the total amount of code is just still literally a few hundred lines of code. Go look at the GitHub repository. So there's more testing code, I think, than actual implementation code. With memory map files, it's so easy to do that stuff.
Any comments on interfaces to the data?
Well, we're still thinking about that. I mean, certainly some form of web service interface, maybe OData, I think is likely. Brian also didn't mention OData, but it's a RESTful web server style interface which has become common for queries as well to relational databases. And what we're trying to decide at the moment is whether we should go for ODBC, or ODBC is really a technology of the past, and we should throw some effort into implementing OData. My time is up, so I'm going to get out of the way. Thank you very much.